Okay? We're going to kick off this second half with a really incredible session. We're going to bring to the stage for a lightning talk, Associate Administrator of Science Mission Directorate for NASA, the one, the only, Nicky. Big round of applause.
That's quite a long walk. Good afternoon, everybody. Delighted to be here. This is my first ISSRDC, and I'm enjoying it very much so far. I hope you all got to enjoy Jim Freeh's keynote at lunchtime. He really painted a beautiful picture of the history of NASA's work in low Earth orbit up to today and forward into our future. Now, being the head of science, I, of course, want to zoom in on the science that we do in LEO, and how also, really stress how it is important to continue and expand these opportunities as the landscape evolves. Now, microgravity in low Earth orbit has enabled some of the greatest scientific discoveries on record. Science done on the International Space Station has redefined our understanding of the universe we live in, quite literally down to the atomic level. In 2018, NASA's Cold Atom Lab on the space station became the first facility to produce the fifth state of matter in Earth orbit, providing new insight into the fundamental laws of quantum mechanics. With the addition of new hardware to the Cold Atom Lab over time, longer and longer observing times and colder temperatures have provided opportunities for deeper insights into the behavior of atoms. And of course, we all enjoyed and congratulated Elliot in picking up his award earlier. Great job, Elliot. And I do have my Cal pen on today, just so you know. Woohoo, Cal. All right. So a wide array of experiments on the space station have increased our understanding of how fluids move and how we can influence or leverage those mechanics to improve processes like drug delivery and thermal transfer. Researchers have discovered that growing protein crystals in microgravity allows for slower growth and higher quality crystals, providing insights into numerous diseases. This high-quality crystallization allows us to identify the structures of disease-causing proteins to develop new medications and very effective treatments. The work that NASA does to better understand our universe and to protect our astronauts often results in direct benefits to the people here on Earth. The International Space Station has delivered an unquantifiable amount of return value to humanity, and it continues to do so today. Studies in microgravity have contributed greatly to our knowledge of bone and muscle loss in astronauts, and more importantly, how to mitigate those effects. This knowledge also applies to people on Earth dealing with diseases like osteoporosis. Some of our most basic human needs can be met better in the more challenging circumstances because of NASA's amazing work. For example, many people around the world lack access to clean water. In pursuit of closed-loop water recycling, technology that was developed for space has allowed at-risk areas to gain access to advanced filtration and purification systems. Now, last year, the space station team demonstrated 98% total water recovery, which is a major milestone set to prepare NASA for future long-duration missions. We're continuing to study water filtration in microgravity and plan to fly an experiment on the upcoming NG-21 resupply mission to test reactor materials with applications for water recovery, thermal management, and fuel cells. Major advancements in medicine and pharmaceuticals made on the space station have improved quality of life and likely even saved the lives of people suffering from a wide range of conditions. Microgravity research has provided new insights into for scientists that are studying diseases like Alzheimer's, Parkinson's, and cancer. Without the interference of Earth's gravity, Alzheimer's researchers can better study protein clusters that can cause neurodegenerative diseases. Cancer researchers have studied the growth of endothelial cells and have even found more effective ways to test new cancer treatments. Experiments in growing plants, including food, on the space station have resulted in agricultural advancements on Earth, allowing us to improve crop growth and allow farming in extreme and austere environments. Now, low Earth orbit is an incredibly critical location for studying our planet, the most important planet, because it's the one we live on. So both through our Earth-observing satellites and also the eyes of our space station crews themselves. And I hope you've seen some of the incredible images that we're getting from our recently launched PACE mission. PACE will help us understand our ocean and atmosphere by measuring key variables associated with cloud formation, particles, and pollutants in the air, and microscopic floating marine life. Also want to give a shout out to EMIT, also just winning an amazing event here. And sadly, I didn't put my EMIT pin on today, so sorry, Rob. But the congratulations to them, allowing us to actually track pollution down to neighborhood levels with hourly views of pollution and as it affects our North American continent. Data from missions in LEO, these observations will help us better monitor ocean health, air quality, and climate change, which is so incredibly important to what we do at NASA Science. So data from our missions in LEO and imagery and observations collected by space station crews inform better simulations, and they allow us to do predictions of wildfires, extreme weather, and dangerous atmospheric conditions. This helps our operational partners as well, like NOAA, as they aim to provide quicker and better responses to disasters and to help us protect communities around the world. This type of information can also help farmers better plan their crop cycles to improve their harvests, help doctors to predict where disease may break out, and provide advantages across many other fields. The benefits of low Earth orbit science to humanity are incredibly far-reaching. In addition to improving everyday life on Earth, this work is critical to our success in exploring the rest of our universe. It is vital, it's a vital proving ground as we address the next decade of science priorities outlined by the Decadal Survey on Biological and Physical Sciences research in space. The International Space Station provides a unique platform for long-duration human spaceflight and an opportunity to study the impacts of this on the human body. Innovative models like 3D tissue chips, personal favorite of mine, I might say, enable researchers to study how a patient might respond to a treatment without the need for the patient to receive it directly. So this may help us tailor supplies like medical kits to individual astronauts so that we only fly what we need on the Artemis missions and other future missions where mass is extremely precious. In situ analysis capability, like identification of unknown microbes, protects human explorers and will allow them to increase the efficiency of the science they do on future missions to the moon and eventually to Mars. Technologies like this, born and nurtured on the space station, will continue to evolve on low Earth orbit platforms and would help us to achieve the agency's Moon to Mars objectives. Beyond our own solar system, experiments on the space station have helped us answer big questions and reveal new ones. For example, the Alpha Magnetic Spectrometer 2 has been looking for evidence of dark matter from outside the space station since 2011, collecting data on more than 100 billion cosmic particles. This experiment has provided researchers around the globe with data that could determine what the universe is made of and how it began. Another achievement that we celebrated earlier today, through an international collaboration with JAXA, the NICA and MAXI experiments working together in tandem to advance our knowledge of pulsars and black holes. Being a heliophysicist, I need to celebrate the fact that last year we launched the atmospheric wave experiment, and that was our first heliophysics mission on the ISS. It was installed on the exterior of the space station to allow us to study colorful bands of light in Earth's atmosphere. And this may help us determine what combination of forces drive space weather in the upper atmosphere and provide insight into how terrestrial and space weather interactions may affect satellite communication. This type of knowledge is critical in support of NASA's sustainability strategy and will help us support a safer future in space and on the ground. Low Earth orbit provides unique conditions relatively close to home. It is kind of that natural first location for many different stakeholders to get experience working in space. The agency has already supported increased access to a number of levels to a wide range of users. Commercially enabled rapid space science, or CIRRUS, aims to accelerate the pace and productivity in space using commercial capabilities. NASA issued requests for information in 2022 to both commercial companies and the science community with an emphasis on in situ sample preparation and analysis. We've made several awards to support the development of improved in-flight sample preparation capabilities and to gather data on plant gene expression and response to different stages of spaceflight. CubeSats have also provided a cheaper way to perform science and technology demonstrations in space. I didn't realize it was this many. I was surprised when I read my notes, but more than 250 CubeSats have now been deployed from the space station, which is amazing. So thank you to the ISS for kicking off our CubeSats. That allows us to jumpstart new research and provide a springboard for new space companies. Increased access isn't just about bringing in new service providers to meet demand. It's literally about lifting up a new generation of scientists and engineers. Numerous NASA programs have given elementary to college-age students access to space and the chance to take advantage of the microgravity environment aboard the space station. This access launches careers in STEM, including students from underrepresented groups, expanding our scientific community of the future and making it more inclusive. So with all of the progress we've made and all of the value we've returned, it's clear we need to continue to take advantage of what LEO has to offer us as scientists, explorers, and as people. This will require all of the excellent partnerships that we have today and new collaborators working together in a robust economic ecosystem that can support the wide array of objectives that we want to see met in this unique location. NASA has a plan to maintain access, opportunity, and our cadence of research in low Earth orbit that reflects the growing space economy of today, which I know you're going to hear a lot more about in the next panel. From the science perspective, we envision a future in which NASA is just one of many entities continuing to explore our universe and making our solar system a better place to live. Thank you so much.
Keep that round of applause going from Nicky Fox. Thank you. Thank you.